All right, for this question here, again, we're back up to this chart, sorry, not this chart, but this box full of information here. So the height of a rider on a Ferris wheel can be modeled using the sinusoidal regression function. And here we've got h is equal to 6 sine of 1.05t minus 1.57 plus 8. Okay? And h is the height and t is the time in minutes. Now, we've already done question 2, so question 3, and I apologize that it's not all on one page here, but that's okay. The time it takes for the rider to reach a height of 10 meters above ground for the first time. Now, the implication here when you see a question like this is that you're going to use your calculator to answer it. So I'm going to come up here, I'm going to enter this equation, and I'm going to look and see where it goes to 10 for the first time. Now, first of all, when I enter this in, remember that word problem should be in radian mode. So I've got to make sure that the calculator is in radian mode, and it is, which is good. So now I press y equals, and it'll be 6 sine of 1.05x minus 1.57. Close the brackets there. Please make sure you do that. Plus 8. Okay? Now, I've already identified, I'm going to play with the window settings here. I've already identified in the previous question that this thing has a maximum value of 14. I don't, off the top of my head, know what the minimum value is, but I know that a Ferris wheel wouldn't go below 0, and it makes no sense. It would be digging underground there. And if the maximum goes up to 14, I don't know, let's go up to 20. Let's give ourselves a bit of room there. Oh, I'm sorry, that's the x coordinates. Okay, what I was just talking about here, I'm sorry, that should have been the limits on the y. So 0 to 20. For the x here, it doesn't make much sense to talk about time less than 0. And for our maximum time, think here, how many minutes would it take to go around here? Well, I'm not entirely sure what that should be. Let's put 5 in there and just see what happens. Okay, nothing wrong with taking a guess. All right. Well, 5 minutes isn't even enough to go around there all the way once. So, but that's okay, because the question's asking me how long it takes to get to 10 for the first time. Now, 10 is a height. Based on the way I've entered that in, that is a y-coordinate, okay? So I'm going to come down here, and I'm going to put 10 in as a second y-coordinate. I'm going to look for where they match. It always takes a little bit more effort when you're given the y-coordinate and asking to go back to the x. It's far easier if they just give you the x value. So now we're going to graph this. Okay. And the question asks for the first time that the rider hits that. So I'm looking for that point of intersection. So we press second, trace to get into the calculation menu, and I'm going to come down to intersect. And all I'm going to do is just move the cursor just so that I'm close to that point of intersection. It doesn't have to be right on it. Its calculator is asking me, am I on the first curve? And the answer is yes. Then it jumps straight down. It jumps vertically. Then it's asking, did I jump to the second curve? And the answer is yes. Then it's asking if it can make a certain guess here. It really doesn't matter what it guesses. We'll be fine here. So just press enter to get past that. And the point of intersection, I know it's probably not visible because it's in red there, but the point of intersection is 1.82 when I round that. 1.82. So let's flip this sheet over. It's multiple choice. Do I get a 1.82 somewhere in here? There we go, 1.8. That's how long it takes to get to 10 meters for the first time.